The following is the video solution from JSDT Solutions. Question 4 says, in the diagram, the circle centered at N passes through A, which is -1 and -1, and C. Then we have B, -4 and 2, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis. And lastly, they tell us that CD is a tangent to the circle at C, and CD is equal to 6 units. And the first question is to write down the length of the radius of the circle. Okay, so to find the radius, we know that the radius goes from the center of the circle to the circumference. But this point, these 2 points, you can see that they share the same x value, okay, -1 and -1, meaning this is a vertical line. So to find the length of this line, you don't need the distance formula. You simply need to say whatever this y value is minus whatever that y value is, and that will tell you the length of the line NA. So we can find the radius or NA by simply saying -3 minus -1. So 3 minus -1, which is +1, and so that is equal to 4 units. And that is the length of the radius. Moving on to the next question. Question 4.2.1 says, calculate the coordinates of C. So looking at C, C is also that other point that is at the circumference. So how to find C? Notice that CD is a tangent to the circle. So it means that when we draw a radius, okay, which we already have the length of, we know that the radius and the tangent are perpendicular at their point of contact. So here's the thing. This is parallel to BE. But we also know something about BE and the x-axis. They told us that BE is parallel to the x-axis. So if BE is parallel to the x-axis, then CD is also parallel to the x-axis, meaning that this, because this line CN, the radius, is perpendicular to CD, a line parallel to the x-axis, then this line is a vertical line. So if it is a vertical line, it means that, you see the point N, -1 and 3, C would also have the same x value, okay, because it's a vertical line. So we literally just move up by the distance of the radius to get to that point. And the x value is -1, making the y value, to find the y value, we already know that the radius is 4 units. So you're moving from N being the y value of 3, and you're moving 4 units up to get here. Okay, so that is going to be specifically here. Okay, that's going to be 7. So that's -1 and 7. And that will also be the coordinates of C. You can show them that you found the y value, how you found the y value. So we knew that the x value of C was -1, okay, because we had that CD is perpendicular to NC. We can call it NC, that's fine, or CN, okay. And so therefore, because it's a vertical line, to find the y value of C, we simply just said that 3 plus the 4 units, just shift 4 units up, and that's 7. So therefore, C is simply -1 and 7. And that is our answer. Question 4.2.2, we need to find the coordinates of D. So D is over here. So that would be the same principle really, because this is a vertical line and it is perpendicular to CD. CD is a horizontal line. You know that the x value here was -1. So we're really just moving from -1, right? And we know that this is -1. And CD is exactly 6 units. So you're moving 6 units to the right to get to D. The only thing that changes, as you can see from this point over here to that point, is the x value. That x value now becomes -1 plus 6, which is 5. And the y value is exactly the same as C, since it is a horizontal line. This was 7 as a y value. This will also be 7 as a y value. So D is 5 and 7. Okay, the only calculation we would really have to put there is maybe the coordinates of 5. Okay, how we found that. So we can just simply tell them that to find the x value of c, we simply set -1 plus the distance of CD, which is 6. And so that coordinate is 5. And so therefore D is simply 5 and 7. And that is our answer. Question 4.2.3 says we need to find the area of triangle BCD. Okay, so let's go ahead and draw that. That is going to be B to C to D. Okay, so this triangle over here. So first, always try to use half base times height before using any other one, okay? Because it's the simplest way to find the area of a triangle. So, do we have a base? Yes, we can use CD as the base of this triangle. It's 6 units. Do we have a height? We find the height by going from the highest point on the triangle to the perpendicular base, okay? Now, the base, because this is an obtuse wall, it looks like, right now we haven't really found any angles, but it looks like an obtuse triangle. What we could do here is simply extend this base of CD. If you extend that, then we can better understand what the height is. The height will go from the highest point, and we can look at that as this point B over here. So if you go down, and we're going to draw a dotted line down to the extension of DC, then you can see that that is the height. Okay, and the height, we can find this because we already know what the y value of C is. It is 7. And we know what the y value of B is. It is 2. So the height is simply the difference between 7 and 2. So that is exactly 5 units. Okay, so this triangle has a height of 5 and a base of 6, so we can find the area. We can tell them that the area of triangle BCD is equal to a half multiplied by the base and multiplied by the perpendicular height. It always has to be perpendicular, and yes, in this case it will be perpendicular to the base because this is a vertical line and that is the extension of that base, which is a horizontal line. So this is equal to a half multiplied by the base of 6 units and the height of 5 units. So 6 times 5 is 30 times a half is 15. So this is 15 square units, okay? Okay, 15 units squared. And that is the area of triangle BCD. Question 4.3 says, the circle centered at N is reflected about the line y equals x. Okay, so this becomes the inverse of that circle. M is the center of the new circle which is formed. The two circles intersect at A and F. So keep that in mind. And they wanted to calculate the length of 4.3.1 NM. So to find NM, we just really need N and M. We know that M is the center of the new circle which is formed. Okay, so let's just get rid of some things here. So the line y equals x is like that. And when we have this line, what's going on is the circle will be reflected across this line. So it will still be the exact same size, same circle, just reflected across that line, giving you the inverse of this circle. Now, a circle is a cyclic shape with the same type of curvature all around. It's not like an oval, so it's going to still be a circle. And how we can see this, one of the ways that we can just work on reflecting this is we're going to take a point. Well, the point that we actually need is N. So let's just use N. And we know that if this is N, when reflected across this line, y equals x, it's going to form the inverse, meaning the x and y values switch places. That is all that will happen. So this being -1 and 3 will now be 3 and -1. Okay, so something like that. And that is M that they are referring to, 3 and -1. And they simply want us to find the length of that. Okay, so we'll just tell them what M is and then find the distance of NM. So here's a visual example of what happens. This will be reflected across that line y equals x. So it's a reflection. Well, it's going to actually flip over, of course, or just form a mirror image. But just showing what happens is that it moves like this. Now, there are certain points that would have to maintain. For example, you see this point A, which is -1 and -1. Notice that its x and y value are exactly the same. So it means that on the reflection, you're also going to have another point called -1 and -1. So it also has to pass -1 and -1. Okay, so maybe something like this. Okay, so something like that, and I would probably just have to write this much closer. So I probably just drew that a little too far. So that would be about here, the center, and that is M. Okay, so that is 3 and -1. And we can just find the length of MN. Okay, so N is that, and so therefore M is this. So we'll have to tell them what M is. And now let's find the distance. So MN, we don't really need the formula. We already wrote it down at some point. So square root of x2 minus x1, we'll say -1 minus 3 all squared, plus y2 minus y1, and that is 3 minus -1, which becomes a +1 all squared. And let's just find the distance of MN. So MN is equal to 4 square root 2. Okay, you can round this off to 2 decimal places, which is going to be 5.66. It's going to round up to 6, so 5.66 units, and that is the length of MN. Okay, and the final question for question 4 says 4.3.2. We need to calculate the midpoint of AF. Okay, so let's go ahead and look at our diagram. So with AF, remember that they told us what F was. They specifically said that A and F, the two circles, they intersect at A and F. So knowing that they intersect at A and F, A is clear, that's here where they both intersect. Remember how A is a point that is -1 and -1. It lies on this line y equals x. So I actually have to correct some things here, the way I drew some things. This line is actually more tilted like this, and then it passes that point A like that. Okay, so something like that, and A has to actually nicely touch that point over there. So do you see that they will both have a point of intersection at A and F? So F is the only one that we don't know. Well, we have to find that midpoint. But here is the interesting thing about this. Remember that this is the same circle, same radius and all, right? It has just been reflected across the line y equals x. So it also has a radius of 5. Notice that if we connect this over here, if we connect these two, A and M, you're going to have a horizontal line. So I should probably also just make this slightly, shorter than what I made it. Okay, so if you connect it, we have a horizontal line, and we know it's horizontal because they have the exact same y value. A has -1 as a y value, M has -1 as a y value. Okay, and if you connect, and it's also a radius, if you connect N and A, it is a vertical line. Okay, we already knew that from the first questions. Now these have the same length. Remember, they're the same circle, same radius. So the radius of the circle was 4 units. Okay, remember from the y value of 3 to the y value of -1. So this is 4 units. That's 4 units. If we also connect N and F, you also see that we have another 4 units length over there and another 4 units over here. This is a square. Okay, so ANFM forms a square because of the symmetry that we have in these circles. So with that being said, so if we wanted the midpoint of AF, it would be finding the midpoint of the diagonal of the square. So that would be the midpoint of NM as well. So just find the midpoint of NM, and that would also be the midpoint of this AF, which is also the other diagonal of this square that we have here. Okay, now this is not something we have to find out. This is by observation. So just to add to this, we can just tell them about the lengths, right? That all of these lengths are exactly the same. And the last thing to do to prove it's a square would be to show them that we have a corner angle equal to 90 degrees. Okay, so we can just show them that AN and AM are going to be perpendicular at the point of contact, because we already knew that this was a vertical line, their x values are exactly the same, and this is a horizontal line since their y values are exactly the same. Okay, so those two things, all the lengths are equal and we have a corner angle equal to 90 degrees. That will be how to prove that a shape is a square. So the length that we're focusing on is AN equals NF equals FM equals AM. So they are all equal and they are exactly equal to 4 units. And we know that AN is perpendicular to AM. Okay, so it makes that shape a square, which is ANFM. Okay, so that is AMFN is a square. And since we know that it's a square, we know that the diagonals would intersect at the same point. To be honest, we didn't really need to prove that it was a square, so you didn't really need this part. As long as it was a parallelogram, then the diagonals would intersect at the same point, okay? The diagonals would bisect each other, meaning they share the same midpoint. So now we can just focus on finding that midpoint. So we're saying that the midpoint of course, we were referring to the midpoint of AF, but of course we don't have F. So to find that midpoint, we'll use the midpoint of NM. So that is equal to x2 and x1, and we're going to just use it there. So that is, let's just say bottom plus top. So that's 3 plus -1, which is -1 over 2, and -1 plus 3 over 2. So the midpoint of NM is simply going to be, that is 2 divided by 2 is 1, and 3 minus 1 is 2 divided by 2 is 1. It's 1 and 1. And we'll also just tell them that the midpoint of NM is exactly the same as the midpoint of AF. So therefore, the midpoint of AF is 1 and 1. And that is our answer. So you could have just shown them this part and then conclude that rather than concluded it's a square, you could have skipped this and concluded that it's a parallelogram. And so because it's a parallelogram, their diagonals would intersect at the same point, meaning their diagonals bisect each other. And then you could have gone ahead to find that midpoint using the formula. Okay, so that is it for this question, and that is it for question 4.